Hello. We are the groups that is supposed to present at 6 p.m. So I would like to ask if we can start now.
Just please wait for a few minutes. Okay, Gildas.
Okay, so we will wait and if you say
You
okay.
hear me?
Yeah, we can wait for a
Yes.
few minutes.
Just we will start in a couple of minutes.
Okay, thank you.
I'm checking the other participants.
All right.
Okay.
Can we
Hello,
start?
everybody.
Hello.
This is the session 7 of International Student Science Congress. I am Mehmet Çevik, the session chair. In this session, we have 4 presentations. The first one is quantum machine learning algorithms. The second one, comparison of optimization algorithms, to be presented by Wafa. She said she's gonna participate in a couple of minutes. And an analysis of mammogram images, MT, yes, Mohammed Mansour.
Yeah, it's me.
Yes, Mohammed Mansour is here. And the last one is to be presented by Abdiu. I think he will sign in a couple of minutes. So, Gildas, you may start your presentation, please.
Okay, let me share the screen now. Can you see my screen?
Yes.
Okay. Hello, everybody. We would like to present you which is on quantum machine learning algorithms, especially in the case of supervector machines. We have done this work with Gazmor, Abdiu, and Omar Halabi under the supervision of Professor Sedat Akleylek from Mass University. So our work is mainly related to supervector machines. In this presentation, first of all, we start with the reason why we have chosen quantum supervector machines and explain classical and quantum machine learning and move from there to quantum and classical supervector machines. After that, we will explain the result of the theoretical and experimental comparison of supervector machine and quantum supervector machines. And after the performance analysis, we present our conclusion and the prospective work. So why have we chosen the supervector machines? We have chosen the quantum supervector machines because these are a kind of algorithm that is widely used in computer science, especially in machine learning for classification. And in theory, it is proven that quantum supervector machines have a huge performance supremacy comparatively to classical ones. So this kind of supremacy can be very useful in areas such as data mining and big data processing. And we would like to see if the theoretical supremacy can be translated into the practical experimentations. So if these were true, then the quantum computing power could be useful for us to take advantage from the interaction between quantum computing and machine learning so as to process data pretty fast. So what is quantum machine learning? Quantum machine learning is the new area that we get from the combination of machine learning and quantum computing. And in quantum machine learning, we have algorithms such as the quantum supervector machines. Those algorithms are algorithms that have been built while being based on machine learning, but taking advantage of the quantum computing calculation speeds. So first of all, what is machine learning? Machine learning is a sub-area of artificial intelligence, which is which is based on the programmation or the use of the development of models that will be useful to get useful insights from data or process those data to get useful information. So you have the supervised learning, unsupervised learning, and reinforcement learning. The supervised learning is the one that is used when we have data for which the input and the outputs are already clearly given before the building of the model. The unsupervised learning is the case when we don't have the outputs, but you have to implement the model so that the model itself will work on the output. And the reinforcement learning is the one that is based on a process of rewarding and punishment so that the model may learn and be useful. Supervector machines are in the group of supervised learning. So what is quantum computing? Quantum computing is a sub-area of physics. So it mainly comes from quantum physics, which main base is qubits. So the qubits are the information unity in quantum computing, and they have different characteristics such as superposition and entanglement. So when we move to those, first of all, the qubit, this is the structure of a qubit. A qubit has such a characteristic which is the superposition, and the superposition is this capacity that allows the qubit to be at the same time in two states. Like for normal bits, the normal bits can be in a state of 0 or 1. But when we take a qubit can be at the same time in the state of 0 and the state of 1, but at different percentages. For example, the one that is on our screen is a qubit that is at 12% on the state of 0 and 88% in the state of 1. So if, for example, we use this qubit to do any operation, it will do the operation while being in both states, 0 and 1. So we can get both results at the same time while using one qubit. But if it were, for example, a bit, we have to do the operation with 0 and do it also with 1 before getting the answer. This is even one of the main reasons why quantum computing has some speed comparatively to classical computing. Now, so the capacity or structure that enables qubit to be at the same time in a state of 0 and 1 is the superposition principle. Another principle is the entanglement principle. The entanglement principle is the one that helps us to have to put two qubits in contact so that even if those qubits are put away or at any distance, they will be able to connect and to share information no matter what is the distance among them. So quantum computers nowadays are as big as those that are on the screen because actually they are not yet transportable easily. They are really big devices that are still under development in our world now. And on those computers, we are trying to implement the supervector machines. So in this section, we will try to explain the supervector machine and move after that to the experimental result. The supervector machines are machine learning algorithms that are used for binary classification and also multi-class classification. So in binary classification, we have the linear supervector machines, which are used when we can separate or categorize our data just by using a straight line. For example, on this example, you see that directly when we take a line, we can separate the two data in two different groups, and our classification is simply done there. The main goal of supervector machines is to establish or to find an hyperplane that will be able to separate the data in such a way that we'll be able to classify the data very easily. So finding this hyperplane is based on the formula that is on the left, Wx plus b is equal to 0. So sometimes the data is not linear. So when you have a data such as the one that we have on this figure, and the data that we want to classify is not a linearly separable data, then we have to move the data from its normal space to a higher dimensional space. It is the case, and to do this, we use the kernel functions. The kernel functions are those functions that enable us to move our data from its normal space to a higher dimensional space, and then in that new space, we are able to devise or to classify our data. So you see, for example, here on the left, the data cannot be directly separable using a line, but on this side, when we move the data from 2 dimension into 3 dimension, now we are able to separate the data and to do our classification. This is done by using the kernel functions. Sometimes we also have the multi-class classification when we use the supervector machines, and the multi-class classification is when you want to categorize our data in multiple classes, for example, 3 or more, if it is not binary. In this type of case, we use the one versus rest multi-category supervector machine. And in this case, we take each class. If, for example, you have many classes, we take each class as one and all the other classes as one other group, and we do as if it were a binary classification, and we get the hyperplane for this situation, and we do it for all the different classes in such a way that at the end, when we gather all the hyperplanes that you have gotten from each class, we build the final optimum hyperplane for the supervector machine. Now, these supervector machines are the algorithm that we try to implement on quantum on quantum computers, and this is what build the quantum supervector machine. As you see, this is the pseudocode of quantum supervector machines. It is an implementation of the supervector machines algorithm on quantum computers. First of all, we try to implement to build the qubit states, and when we get the data or our input, we try to transform the data from its normal state to a cubical state. When you get to the cubic state, then we build the kernel functions. We calculate them using matrix calculations, and from then we build our model and we do the classification. So theoretically, when we want to compare the normal supervector machines and the quantum supervector machine, we see that both of them, they are supervised. They are algorithms of the supervised learning in machine learning, and they are used mainly for classification, sometimes for regression. And the main goal of the algorithm is to find the hyperplane or the surface that will be able to divide the data into different categories while allowing to have the maximum margin among the data. So one of the main differences when we look at the theoretical comparison of the two algorithms is that the complexity of the classical supervector machine is m squared times n. So this is a cubic complexity, while the one of the quantum supervector machine is logarithmic. So this shows an exponential speedup comparatively between the quantum computers and classical computers when we implement the supervector machine. So our main work has been to really implement practically those two algorithms and to see if, as theoretically the quantum supervector machine has an exponential speedup, if this exponential speedup can be seen also in the practice, or if it is only theoretical. So we have implemented.
Last 5 minutes.
Please?
Last 5 minutes.
Oh, okay. All right. So we have done this. We have implemented our algorithm on the classical computer and the quantum computers. When we implement our algorithm on both, we find out that on the classical computers directly, we get an accuracy of normally 90% on classical. When we use classical supervector machine, but when we implement it on quantum computers, there are two cases. There is the case when we use the simulator and when we use the real quantum computers. When we use the simulator, we get an accuracy of 95%, but it takes a long time because on the simulator here, you will see that it takes seconds on the simulator, while on normal computers and quantum computers, it takes milliseconds, because on the simulator, we are trying to simulate the quantum state on a normal computer. And this takes really time because a normal computer, it will be hard for a normal computer to implement the states of a quantum computer. But we get a high performance, which is of 95%. But when we try to implement the supervector machine on real quantum computers that are made available by IBM online, we find out that the performance it is pretty low. We get a performance of 70%, and we wonder because normally, according to the algorithm, the performance is supposed to be higher. So the reason of this is normally the noise, because actually quantum computers are victim of the noise factor, and the noise factor is the main source for which the quantum computers are not working to the optimum performance. And now IBM is working to using a noise mitigation framework, which is IGNIS, and we hope that maybe after the full development of this framework, we'll be able to use this framework for the noise mitigation so as to have more performant quantum computing results. So actually, as a result, we find out that theoretically speaking, quantum computers are faster than classical computers because when we look, for example, at the supervector machines algorithm, the quantum supervector machine algorithm has a logarithmic complexity, while the classical one has, how do we call it, has an exponential complexity. So the fact that, but when we do the practice of these two algorithms, we find out that in practice, it is not the case. The quantum computers have a lower result because of the noise factor. So in our future work, we are thinking about working on how to mitigate the noise. So the diminution of the noise factor so as to get really better performances on quantum computers and to apply it for other quantum computers. Thank you for following us. And now we welcome your questions. Thank you.
Yes, thank you for your quantum presentation. You were just really working like a, or speaking like a quantum computer, quantum speaker. Very, very, very fast. Now, I may take the questions. Did you hear the presentation of Professor Çetin Koç in the morning, Gildas?
I followed a certain part when he spoke about the supervisor machines.
Yes.
And its
Yes,
use.
he talked about these machines.
Yeah,
I think they are the machines of the future.
exactly.
And in near future, we will face them more. Any questions? No. Then we may continue with the second. Thank you, Gildas, for the nice and fruitful presentation. Wafa will present abstract comparison of optimization algorithms for the V2X communications based network slicing. Yes, Wafa.
Benim ekranım share edeyim mi hocam?
Evet, şehir yapabilirsin. Tamam mı şimdi? Gildas, where are you from, by the way?
I am from Benin, but I've finished my study in Samsung.
Yes, okay.
Olmuyor hocam.
Wafa açtık şeyi ama bir daha edelim bakalım.
Şimdi görebiliyor musunuz?
Yok, gelmedi şu anda. Şu anda olması lazım aslında.
Şöyle. Oldu oldu.
Evet, şimdi geldi.
Teşekkür ederim hocam. Hello everyone and welcome to my presentation. Let me introduce myself. I am Wafa Hamdi, PhD student at Ege University, Department of Computer Engineering. I'm so glad to be with you today to talk about the optimization algorithms for the V2X communication-based network slicing. I have divided my presentation that way. In fact, I will focus on three major issues: 5G and features, network slicing for V2X communication, and its application for 5G V2X domain. So, the question is about what can 5G do or provide to us. The shift to 5G will certainly change the way we interact with technology. It will digitize and mobilize traditional industries to give what we will call Industry 4.0. It will react in multi-domain performance like autonomous vehicle, mass market personalized. We will have TVs without or no more need for cables or boxes. Sensors will be everywhere. Vehicles can communicate with each others. We will have a very easy life. So 5G is expected to serve not only the telecommunication itself, but also the whole information society. It will be able to support many more connected devices, 1 million connected devices per square kilometer with low latency, which is about 1 millisecond. A high peak data rates that can hit 20 gigabytes per second in downlink and 1 gigabytes in uplink per connection. For the mobility, with 5G, base stations should be able to support movement from 0 to 310 miles per hour. Such mobility can be a challenge on new millimeter waves network. For building a better connected world and such a huge network, 5G will be able to give these services that I mentioned before, thanks to many different technologies such as full duplex, beamforming, massive MIMO, device-to-device communication, network slicing, which is based on software-defined network and network function virtualization, radio data, and mobile cloud computing. To increase the investment all over the world, there is cooperation all over the world between many countries. For example, in Turkey, there is 5G TR, which is working in cooperation with Japan to improve and to make the installation of 5G in Turkey. More specifically, let's see new possibilities added by 5G to the 4G. The 5G will improve multiple connections at the same time. From functional point of view, the most logical approach is to build a set of dedicated networks, each one adapted to serve one type of business customer. This solution couldn't be realized because it will be high cost. So, as much more efficient approach is to operate multiple dedicated networks on a common platform. This is what we call network slice, and this is what network slice allows. This is why it's considered as a radical change that makes network management flexible and open a new horizon for network efficiency. So it's considered as the key technology for the 5G communication. The important objective is to support 3 generic servers with vastly heterogeneous requirements, which are massive machine type communication, enhanced mobile broadband, and ultra-reliable low latency communication. URLC service, as referred to critical communication, which is usually used for public safety users, is especially in the field of V2X, or what we call VANET communication. There exist so many use cases and servers in this field. We have considered them into 3 categories, as you can see in my presentation. The first one is telematics, such as automated parking, health monitoring, navigation, and so on. Infotainment service is the main objective to this use case is to enable a more comfortable and pleasure for driver and passengers. They can use social media, they can listen to music, they can play games and enjoy their trip at the same time. And the third case is traffic safety and efficiency service that aims to provide information in order to reduce the possibility of traffic accident and improve traffic efficiency. So we can save more people, we can make our roads and traffic more efficient and safe. For this kind of service, which are traffic safety and efficiency service, low latency and high reliability are considered highly demanded requirements. So we need that our urgent message or in emergency case came to users in low latency, so it didn't take time because it's emergency case, and there is a high reliability between VANETs or cars. For these reasons, we choose to consider both latency and reliability as factors to make comparison between the algorithms that have been used in the research area. Here, as you can see, the most relevant used algorithms. Among them, there are those who use spectral clustering algorithm, the option 1, as you can see, followed by a slicing algorithm to allocate slice leaders, SLS, which are responsible for the quality of service, to each cluster. Other, they choose to use low complexity heuristic algorithm composed with 3 steps, which are spectrum allocation, admission control, and spatial multiplexing. The machine learning techniques as an emerging method, as my friend mentioned before, was used in many works like the option 4, 5, also 7, Like deep reinforcement learn, genetic algorithms are located with fuzzy logic, which is an extension for cloud computing and what we call edge computing, which provide the access to the information directly between users. No need to communicate the data center. According to the whole results that we can see, the most efficient method was number 5, which provide a latency of V2X about 0.13 seconds, which is an excellent result. Other one, they used Markov decision process as deep reinforcement with deep reinforcement learning. Other one, they used Euclidean norm theory and network slicing algorithm. But as I mentioned before, the most successful method was the option 5.
Last 5 minutes.
Okay.
5 minutes.
Okay. Just there is 2 slides. The research work that has been carried out in the area of latency and reliability optimization of V2X network in 5G remains insufficient because there is so many several factors that must be taken into consideration, such as handover, security, the failure of transmission in the case of critical emergency message. It will be a bigger trouble. The protocols using for routing, the integration of artificial intelligence technique. They started to integrate artificial intelligence technique, but it's still not enough. Data plane isolation and control plane isolation, and so on, so on. This option and challenges can be used in further research papers. And this is it. This is my in my works, my used references, works cited. And thank you for your attention. Also, thanks to İzmir Çağrı University and İzmir Uluslararası Misafir Öğrenci Derneği.
Wafa, thank you for your nice presentation. And let me take the questions.
Okay.
Levent Hocam, yok mu soru? Mansour? No questions. Gildas, do you have any questions? Ben bir soru sorayım Wafa. Gildas, var mı soru?
Yok, teşekkürler.
Yok. Sunumun baş tarafında şöyle bir şey söyledin. Bunlar easy life sağlayacak diye. Hayatı kolaylaştıracak diye. Yani ben bakıyorum, hayatımız kolaylaşıyor mu, zorlaşıyor mu tereddüt ediyorum. Gerçekten kolaylaştırıyor mu bunlar, yoksa kontrol altına mı alıyor hayatı? 5G. Bugün aslında çok gündemde olan bir konu. Çok tartışılan bütün dünyada. Hatta biliyorsunuz komple teorileri var. Bu koronanın bile bununla bağlantılı olduğu
bazıları
şeyler var.
Evet.
Yani
ama
konuda...
o hocam öyle bir şeyler de gerçek değil. Yani sadece yanlış haberler. Yani The Five Generation koronayla bir alakası yok yani. Tamam, biz her zaman yeni şeylerde bir şey söylüyoruz. Double edge weapon. Yani bir silah hem de 2 tane tarafı var. Yani insan onu kullandığın zaman da ona ait. Ya da kontrol altında kullanacak ya da serbest bir şekilde kullanacak. O zaman da tehlikeli olacak.
O konuda haklısın. Hani ben de açıkçası çok o komple teorisine inanıyor değilim ama bunlar aslında hayatı kolaylaştırıyor mu, yoksa her şeyi bir kontrol altına mı alıyor? Yani kolaylık...
Hocam sanki soru bilgisayar mühendisliğine değil de sosyal bilimlere sorulması lazım gibi. Yani Vafa'nın bu konudaki cevabı, bilgisayar mühendisleri bunu yapıyor. İşin ahlak tarafı, felsefe, sosyal tarafı da diğer fakülteler yapsın diyor herhalde. Öyle anladım ben.
O yüzden hocam mesela ben infotainment service, pleasure service seçmedim. O yüzden safety service seçtim. Ahlaki
Yani
taraf seçtim.
biz geliştirelim felsefeciler, yani bunu doğru kullanıp kullanmamak
Düşünsün.
konusunda sosyolojiler geliştirsinler diye düşünüyor herhalde.
Evet.
Evet.
Evet, güzel bir
Hocam
çalışmaydı yani
haklısınız
bence.
ama çalışma güzel gerçekten.
Evet.
Siz de haklısınız Levent Hocam ama artık bu şeylerle o kadar yüz yüze kalıyoruz ki insanın
Evet.
aklına her şey geliyor. Yani her gün bunlarla ilgili bilgiler, aslında bu konu gerçekten çok güncel bir konu.
Mesela
Hayatımızı
hocam
çok yakından ilgilendiren.
ben şöyle düşündüm mesela kaç aydan önce İtalya'da bir olay oldu. Çok büyük bir köprü düşmüştü. Eğer benim söylediğim yani servisler şeylerde o zaman da olsaydı yani kaç tane insanın canı kurtarabilirdik.
Evet. Doğru, yani bunların söylediğin gibi iyi tarafı da var, kötü tarafı var.
Aynen.
İyiye kullanırsan
Her şey öyle.
işe yarıyor. Evet.
Teşekkür
Thank you for your
ederim hocam.
presentation. And now our last presentation, I say last because I called Abdurrahman the last. He said that they will not be able to present. So Mohammed Mansour will make the last presentation today. Yes, Mohammed, it's your turn.
Shall I share the screen now? Okay. Share screen. Do you see my screen now? Do you see my screen? Is it clear?
Yeah.
Yeah. Yeah. Let me introduce myself. This is my name is Mohammed Mansour. I'm from Palestine. I have just finished my master the Department of Mechatronics Engineering at Sakarya University. My presentation will be about analysis of
Mohammed,
yeah.
Mohammed, by the way, where are you from? I couldn't understand.
I'm from Palestine.
From?
Palestine.
Philistine. Okay, Mohammed. Yes.
Yeah, I have just finished my master at Department of Mechatronics Engineering last month. My topic will be about analysis of mammogram image for breast cancer detection using data mining different techniques. Actually, in my outline, I have introduction about data mining and the scope of an objective of my work. We will see a little bit information, technical and medical background about data mining, digital image, and breast cancer. Then we will see the research methodology that I have did. Then we'll go to clustering technique, classification technique, and we will discuss the results. So data mining is known as a knowledge discovery database, which is a new technology that concerns extracting useful information from a large amount of data set. We know breast cancer is one of the most dangerous diseases that women all around the world suffer from. Segmentation of cancer image is really an important topic, and now new technologies are focusing on making a new algorithm or hybrid algorithm to extract the abnormal region that appear on the mammogram image. Actually, mammogram is one technology from different type. It depends on X-rays, and there's another technology which is depending on sound, like ultrasound, and also there's a microwave technology, and there's also magnetic technology, which all of them take image for the breast of breast cancer. So in my work here, actually, we took the image, we prepare it using different digital image processing tool. We filter the image, extract the important part. Then we use two clustering algorithm, which the first one is K-mean, the second one is fuzzy mean, to cluster the image and make different, let's say, different clusters or different classifications to extract the abnormal part in the image. Then we classify the cancer data by using artificial neural network and support vector machine and k-nearest neighbor. So we classify the data that is extracted by clustering algorithm to build a system that can which can classify the cancer data to say to us if it's benign or malignant image. So the scope of my work, actually, we prepare the image using different digital image processing tool. Then we segment segment the image using clustering algorithm. Then we classify the cancer data. All of our work actually and the codes were prepared and written using MATLAB program. So for data mining, let's say here it's a representation about data mining. We have data, we have to filter or prepare the data, then we have to apply the, let's say, the appropriate algorithm to extract new knowledge from the data set. This is a different presentation about data mining. I will go to preparing that. Actually, we have here let's say the data set that that we use. I will show it directly. This is information about breast cancer and the breast cancer, the difference between normal cell growth and cell cancer growth. Actually, breast cancer, it started from the TDUL, which is terminal duct library unit. This is the origin of breast cancer. The main difference between the normal cell growth and the cancer cell growth, we have two types of cancers. We have benign or malignant. When it's benign, it's okay for and the shape are regular. When it's malignant, actually it is not regular. Now I will go to directly to the outline of the research. We input the image to the system, then we pre-process the image using different digital image processing tool. Then we apply clustering algorithm. Then we classify the cancer data. Here is a presentation about our data set. We have 10 normal image. Then we have almost 35 malignant image, and we have 35 benign image. The first step is preparing of the image using different digital image processing tool. As appeared here, for example, we have some labels appears on the image. We have to extract all unimportant data from the background of the image. So we apply, actually, we use median filter. We use again also, we removed all the label and the line using a morphological operation. Then we extracted the muscle from the background of the image. Then we use some filters to enhance the image. So I will show you the result of median filter. As it's in the left side, there are some lines appears. When we use median filter, it's okay. Then you have to extract the labels that appear here. For example, GM. This is actually we had problem with having data set. We took this data set from internet actually. Then we extract these labels using some morphological operation. Actually, we use some dilation and erosion technique. I will show you the direct result of the preparing of image. We change the image format to binary. Then we apply this technique to extract the labels, and the result of preparation it appears here. Then actually we extracted the muscle part. This is the muscle part. Let's say I will show you the image. We have here in the left screen muscle appears. Then we change the image. We implement an algorithm to extract this part. And the result is it appears here. After this step, actually we can start. This is as a present example of the result of normal image, and we have also malignant image and benign image. After this step, we can apply the clustering algorithm to extract the abnormal part that appears here. So we want actually to extract just the abnormal part to use the number of pixels in the classification algorithm to cancer with the already given cancer data to make to have a conclusion about the patient information, if it's benign cancer or malignant cancer. So the first one, after this step, actually we use some filters to enhance the image. I will show you the result directly. We use unsharp filter, Gaussian filter, and the last result it appears here. After this step, we use clustering technique. We use the k-mean and fuzzy mean techniques. Actually, k-mean depends on distance function for implementation. The implementation was done in MATLAB environment. This is an algorithm of the implemented algorithm. The result, actually, I can show you the result directly. We have, let's say, the original image. We clustered to 5 bars using k-mean. This one in the left side, it's a normal image, so there is no cancer case. In the right side of the screen, there is a cancer appears here. Actually, we wanted to just, if you could look at cluster number 5, we have the cancer area here. After extracting these bars, we are taking the number of pixels This cluster way actually it depends on the intensity of the pixels, which means if it's cancer, the intensity of pixels are really very high if we compare it to other pixels. And here's a representation of benign image. If you look at cluster number 5, here we have result of the clustered part. Actually, we use all the data set. We have almost 80 number of image. We have normal, we have malignant, and we have benign. Actually, we implement the algorithm to make a difference between the algorithm. If it's we have to compare the result of algorithm. We have runtime and we have average memory kilobyte, which is the used memory by image to save the image in the computer. Then we use actually another algorithm which is called fuzzy semi algorithm. It depends on the fuzzy membership function. Actually, this algorithm allows the data to be in content of more than one type of clusters. I can show you the result directly. Actually, we could cluster the image just to 4. In fuzzy in Kemin case it was 5, but now it's 4. The first one is normal. The second one is malignant. It appears in the first cluster, and also for in the right side of the screen we have also for benign image. After this step, actually we calculated the extracted number of pixels in Excel sheet, and we entered the classification algorithms. Here we have a representation about the extracted number of pixels. We have also the runtime that's used by the algorithm. We have also the average memory space. Actually, we wanted to, for this project, actually, we have more than one aim. One of them to see the differences of equality between the used algorithm, Kemin and fuzzy semi. Kemin could cluster the image to 5 clusters. Fuzzy semi could cluster the image to 4 clusters. And the runtime of Kemin, it was lower than the runtime used by fuzzy semi. This is the main, let's say, the first aim of this project. Then we use the three type of classification algorithm. We wanted to build a system by using the extracted data from the clustering algorithm with the already given data about the patient. For example, we have the sex of the patient, we have the age of the patient, we have some information about the hepatic days about the patient with the number of pixels extracted by the clustering algorithm. We use the 3 type of classification algorithm. We have automation neural network, we have support vector machine, and we have KN and K-nearest neighbor. Actually, we wanted to see the different accuracy of this algorithm. The highest accuracy was by using automation neural network. Actually, I think all of you know about artificial AI, and all of you new technologies now using it. We have to input the data to make, let's say, a system which can we have to, train the data to make a system that can classify the data in the future. Use AML, which depends on the normal human neuron system, and we have also support vector.
Mansour, last 5 minutes.
5 minutes, okay. And also the second algorithm was support vector machine. I think all people now today spoke about support vector machine as well. And we use also nearest neighbor. So when we classify the cancer data, we have, let's say, if it is, for example, we already it's supervised and unsupervised. This is supervised one, and testing was unsupervised. That means we give the output to the system. So, for example, if it's true positive or true negative, false positive or false negative. So we have some, let's say here, accuracy, and we have region, we have recal, we have F1 major. All of these are some, let's say, predefined equation to see the differences between the accuracy and also the result of, to compare the result of the different algorithms. The highest, actually, this is the ANN result for malignant and for benign. We have also accuracy almost 0.97 for both of types. For KNN, the accuracy was almost 0.94. For CVM, it was very, very low. It's almost 0.52. So I will show the result again of all the gathered algorithm, all the gathered clustering. We have average runtime for Kemin algorithm, and we have average runtime for fuzzy semi. Actually, Kemin clustered the image this time than fuzzy semi. For the memory, for the used memory space, fuzzy semi can cluster the image with, let's say, Kemin cluster the image with low memory space. If we compare it to Pazmi take higher memory space. And also this is another representation for the runtime. So this is the space complexity, and here also we have the classification algorithm evaluation. We have robust to brace for specific. Actually, we are considering about the accuracy. The accuracy of the algorithm and was really high. Sensitivity also was high. Specificity was very low. This is all actually about my. If you have any question, I can. Thank you very much for having us today. I was really very quick with speaking. Actually, this is let's say 100, almost 100 slides. Was my master thesis actually. I tried to give you information in a very quick way. If you have any question, I'm ready to hear.
Thank you also, Mohammed, Mansour, for your presentation. I understand that in the next years, we will have to get used with computers and support vector machines, neural networks.
Actually, to be honest, all of these algorithms are old now, but if we really want to enter the technology, we have to build our own algorithm, which is hybrid algorithm.
Yes, different types of algorithms.
Yeah, hybrid algorithms. I was really.
Does anyone have a question? Wafa, Gildas? Yes, Wafa.
First of all, I want to thank him for his work. Really, I appreciate what did they make. Just a little question. You mentioned that you had used a dataset from the net.
Yes.
Just I want to know why you didn't use your own dataset.
Yeah, actually, we couldn't get here in Sakarya University. Sakarya became two Sakaryas, Sakarya Applied Science and Sakarya University. For us, we had registered before the separation of the school. We couldn't manage. For example, my advisor in the second university, we couldn't get information from the dataset from hospitals here. This is we couldn't, work as we want.
Okay, understand.
Yeah, it's much better if we use original dataset. Is much better. We try to take some information from Palestine, from Ramallah.
Yeah, I know.
We couldn't actually work as we want, unfortunately. But our records are ready now. We can imply any coming dataset. The most important thing is the code. The code is all of the codes are implemented in MATLAB. We can just apply any gathered dataset, let's say.
Thank you.
I can share it with you if you would like. Yeah, I can give you some information.
With pleasure. Thank you.
Welcome.
Okay, if you have time, I have one couple of questions. We have time.
Yes, we have time, hocam.
Okay. The last question. Actually, I couldn't catch the slide because of the fast changing, right?
Yeah.
And the good presentation, right? This is good presentation, but the fast changing is very difficult to see the slides and the numbers, right? Therefore, it is very difficult for me.
I can repeat again if you want. Which part exactly?
Okay, no problem. I have a couple of questions, and
they have quantum brains, hocam. They have quantum brains working very fast.
Okay, my question is about the enhancements of the picture, right? Is it a problem in the prediction of the picture problems, the cancer cell, right? Did you understand the question? The enhancement of the picture is a problem for you in the prediction of the correct area.
Cancer, yeah, actually, since this type of clustering algorithm depends on the intensity of prediction. That means the intensity of cancer area is, let's say, higher than normal part of cancer. The intensity of predictions is really higher.
The intensity is higher in the cancer part.
Yes.
Am I right?
Which is, you are right. This is help us when we cluster the image. If, for example, if you have to play with your algorithm actually until you get, let's say, appropriate results.
Ya hocam, yani şöyle bir sorun var. Yani ses bu şekilde çıkıyor. Yani Dışarıya kelimeler çok seçemiyorum da.
Evet, maalesef
Anlayabildiniz mi Mehmet
arkadaşın
hocam?
bağlantısı biraz
Bağlantı
zayıf
değil
geldi.
hocam, sanki mikrofona şu şekilde konuşuyor gibi. Yani bu
Evet,
çok
Mansour,
anlaşılmıyor. Biraz böyle tane
biraz,
tane ağzı açarak konuşabilirse.
evet.
Right, by
Kulaklık varsa
opening the mouth, right? By opening the mouth as a speaker, right? Opening
you
the
have
mouth.
something like this, Muhammed.
Yes. Actually, I don't have mic in my computer. I have.
Ha.
Yani
Şimdi daha
gerçekten
iyi geliyor.
Evet.
This is now better. Don't move and talk.
Evet ha.
Yes, talk now, Muhammed. We are listening to you.
Okay. I will repeat the information again. When you actually you have to, for example, in here we have let's say cancer data. It difference. It depends on the data set that we have and the way that we want to cluster. For example, people use clustering for different aims, but here we have let's say a clear difference between the pixels, which is the content of the image. The intensity of cancer bar is different from normal part of the image. And clustering algorithms, this one, positioning and timing, they are medical, let's say medical, they are using for medical purposes. Can cluster the image based on the intensity difference between the content of the image. Did you receive my idea?
Hocam ben yine çok anlayamadım ama Türkçe olarak aslında şunu sormak istemiştim. Yani bu bilmiyorum siz anlayabildiniz mi? Muhammed miydi ismi?
Muhammed.
Evet, Muhammed Mansour.
Ya Muhammed, aslında şunu söylemeye çalışmıştım. Çok anlaşılmadı açıkçası, yani biraz geliyor. Uğultulu geliyor ses bana.
Evet.
Şöyle, yani biz kanserli bir bölgeyi tahmin etmek için resimlere bakıyoruz ama benim anladığım kadarını anlatayım. Bu resimler çok böyle çözünürlüğü yüksek olmadığı için karar vermek için bunu daha iyi hale getirmek istiyoruz diyorsun ya.
Evet.
Şimdi orada aslında bir prediction kullanarak daha iyi hale getirmek istiyorsun. Yani senin bir takım varsayımların var ve o flu görüntüyü daha net hale getirmek için bir takım işlemler yaptırıyorsun matematiksel.
Aynen. Dijital görüntü işlemleri kullanarak. Aynen. Dijital görüntü.
Tamam. Şimdi benim problemim aslında şu. Yani orada yapılan şey aslında bir tahmin yürüterek aslında daha net bir hale getiriyorsun. Yani orada yapılacak ufak bir hata, o tahmindeki matematiksel modeldeki bir kayma ya da işte yanlış bir yöneliş aslında sanki kanserli olmayan bir noktayı da kanserli gibi gösterebilir mi? Böyle bir tehlike var mı diye soruyorum. Yani bu anlaşıldı mı? Bunu mu anlamıştın zaten daha önce de?
Aslında
Başka bir şey mi anlamıştın?
actually we prepare, let's say we prepare the image, then we cluster the image. We don't classify the number of pixels alone. We use the pre-given cancer data. Yani görüntü yanında hasta hakkında birkaç tane bilgi var mesela. Onları kullanıyoruz. Hepsini ondan kullanıyoruz. Bir anda kullanıyoruz. Sadece görüntüden çıkaran bilgi değil.
Tamam, yani görüntüyü netleştirdiğiniz zaman peki bu net görüntüye %100 güveniyoruz, öyle mi? Net görüntüye güveniyoruz.
Aslında biz classification algorithm result bakıyoruz ya, accuracy. Hangisi en yüksek accuracy alıyoruz mesela?
Yok benim sorum o değil ama o bir sonraki aşama. Yani sen şu an datayı yani görüntüyü netleştirdiğinde oradaki görüntünün netliğine bakarak aslında bir sonraki aşamada o accuracy'ye bakıyorsun. Benim sorum bir önce, yani datayı toplarken ki süreçten bahsediyorum ben.
Evet.
Anlatamadım herhalde ama.
Anladım. Aslında biz dataset alırken yazıyorlar mesela bu image benign ya da malignant. Yani hangi kanser türü?
Ya şöyle yapalım istiyorsan biz ayrıca ben
Evet.
senin mail adresini falan alayım da birebir böyle soracağımız sorular oluyor.
Evet.
Yani yazılı olarak da bunu paylaşıp konuşabiliriz. Yani şimdilik bu kadar.
Belki bilgi kitabında da olur.
Evet, orada bir paylaşım yapılabilir, evet.
Bilgilikte. Yes, are there any other questions? Gildas, do you have any? No. Okay, thank you all the participants. This was a nice and
benim aslında hocam bir sorum daha vardı aslında. Ben
varsa,
ekstra arkadaşlar son, yani kapanırken eğer çok vaktimiz varsa 2 dakika daha çok uzatmadan sorayım.
Alalım hocam onu da.
Yani data mining prosesini nasıl tanımlıyorsun diye ben aslında soracaktım. Bunu yani ENN'den, fuzzy logic'ten ya da regresyon analizinden ayıran bir şey var mı? Yoksa bunların tamamına mı biz diyoruz data mining? Tam olarak bir cümleyle nasıl tanımlarsın? Data mining nedir dersi? Yani böyle bir verilen bir datadan ara değerlerdeki sonuçları şey yapma yolu mu? Data mining dediğimiz şey. Tahmin etme yolu mu?
Data mining, shall I give you the answer? Actually, data mining consists in extracting useful information from a large amount of data set using different technology. It can be machine learning, yani makine öğrenmesi. It can be statistical approach. It can be mathematical approach. Yani machine learning aslında bir data mining kullanmak için bir teknolojidir. Başka yani birkaç tane teknoloji var. Machine learning bir tane teknoloji gelir. Anlatabildim mi?
Data mining diyor,
Evet.
çok fazla miktardaki verinin içinden kendi işinize yarayan veriyi seçmedir. Machine learning de bunun yöntemlerinden bir tanesidir. Başka yöntemler de var diyor. Doğru mu Muhammed?
Aslında hocam yani bu tanım bence doğru değil yani. Ben aslında oraya takıldığım için bunu soruyorum. Çünkü yani bizim machine learning'de yaptığımız şey bu data seçildikten sonraki süreçte tahmin aşamasında devreye giriyor. Ama bu arkadaşın anlattığı şey yani data mining yani biraz farklı. Yani kavramsal şeyler var şu an anlaşamadığımız. O yüzden tekrar aynı cevabı alınca yani kavramsal
Evet.
olarak iki ayrı şeyden bahsediyor gibiyiz. Bence birebir de görüşmek lazım.
Evet, inşallah kısmet olursa yüz yüze yapmak lazım hocam bunları.
Ha yok hocam sadece yani Gildas'ın mesela sesi çok net geliyordu böyle.
Evet.
Ama Muhammed miydi
Evet,
isim?
Muhammed'in biraz
Ya Muhammed'in biraz böyle geliyor. Beni bilmiyorum ne kadar rahat duyuyorsunuz da ben sizi mesela çok net duyuyorum Mehmet Çevik hocam.
biz de duyuyoruz hocam. Şimdi bu oturumda en zor
Evet.
duyulan Muhammed'in sesiydi. Cızırtılı geldi çok.
Ben seçemiyorum yani onun şeyini de.
Evet.
Kelimelerini onun için anlaşamadık ama yani güzel bir sunumdu ama bir ayrıca konuşalım isterim.
İnşallah. İnşallah.
Farklı iki şeyden bahsediyoruz çünkü.
Evet. Peki o zaman herkese teşekkür ediyorum. Katılımlarınız ve sunumlarınız için. Hande bir toplu fotoğrafımızı alırsan
Hocam şöyle yapalım.
evet Muhammed kıpırdamayacaksın. Sabit dur ha. Tamam. Teşekkür ederiz arkadaşlar.
Teşekkürler.
Bugünkü oturumlarımız sona erdi. Yarın sabah devam edeceğiz. Sizleri de bekleriz. Hepinize iyi akşamlar diliyorum. Görüşmek
Hocam
üzere.
yemeği nerede yiyeceğiz?
Hocam yemek de uzaktan.
Servis
Herkes
kaldı mı
kendi
hocam?
evinde. Evet bu sene öyle oldu. Vallahi inşallah seneye yüz yüzeye döneriz. Bu
Evet, amin.
çok
Zor.
keyifli olmuyor ama hiç
Hocam
yoktan
bence
iyidir
başarılı oluyor
diyoruz.
ya. Yani şaka bir yana
Evet.
gerçekten ben beklediğimden çok daha iyi gidiyor şu an.
Biraz gelişirse bu altyapılar,
Evet.
cızırtılar, ses kayıtları daha güzel olacak. Yani birçok şeyden bahsediyoruz ama daha o noktada yeterli düzeye gelemedik herhalde.
Olsun ama hani sizin taraftan bir sıkıntı görülmüyor. Yani o şu an koordinasyon merkeziyle ilgili bir pürüz yok. Evden bağlananlara şahsi böyle mikrofondur, internet bağlantısıdır gibi
Oluyor
sıkıntıları
tabii.
ona yapacak bir
Tabii.
şey yok zaten.
Evet.
Tamam,
Evet.
kolay gelsin. Görüşmek
Teşekkür
üzere.
ederiz
Teşekkür
arkadaşlar.
ederiz.
Hepinize iyi akşamlar.
İyi akşamlar.
كيف كانت؟